Okay, hello everyone. I see Riley is online. Ben is saying hello. So hey, we're going to take a look at the practice test that we worked on yesterday in class. And I'll go over some of the problems, and then if you have any questions, make sure and leave a comment, and I'll be looking at the comments and answering any of your questions. So we can do a little of that, and if we want to do a little bit of IXL, we can take a look at IXL as well. So let's get started. So this first one here, f of x is equal to 3 plus absolute value of x minus 1. And we want to know what is the value of the derivative f prime of x at x equal to 1. So we need to take the derivative of f. We can start out term by term. So this first term here is just the number 3. So the derivative of any number is just going to be 0. So we have f prime of x equals 0. And then it comes down to this absolute value function. So what you want to remember is absolute value functions are really two parts. So you have the positive and then you have the negative of that absolute value function. And the way to determine where each of those parts start is whatever is inside of the absolute value, so in this case x minus 1, set it equal to 0 and solve for x, so we get x is equal to 1. So that means we're going to have x minus 1, the positive side of this, when x is greater than 1, and then when x is less than 1, we're going to have that negative version there. Hey Tiffany, I see you're on there. Hello. So we have the two parts there, and we want to find the derivative at x is equal to 1. So that means we're going to use the part where x is equal to 1. Well, that's tricky here because what this function actually looks like, it goes up 3, and then we have just this, oh sorry, it shifted over by 1 also. So when x is equal to 1, we have a corner. So if we have a corner, that means that our derivative does not exist. So altogether, this f prime of x does not exist. Because it's an absolute value function, if we were looking for the derivative, let's say at x is equal to 2, then it would exist because it would come from this function right here, and all you would do is take the derivative at x minus 1, which is 1, and so the derivative at x equal to 2 in this case would be 1. However, because we're looking for the derivative at x equal to 1, there's a corner right there. We can't find the derivative. Okay, so that is our first example here. Anytime you want to take the derivative of an absolute value function, you want to make sure that you split it apart, and then you take the derivative of each of those two parts. All right. Number 2, we need to take the derivative of f of x, which is sine of 2x, and we're going to be plugging in pi over 2 to that. So what I'm going to do is take a look at this function. We see that there's a trig function, so we have sine of 2x. So that 2x is plugged inside of the sine function. So this tells me that we're going to have to use the chain rule. We have one function inside of the other. Now if this was written as sine x 2x like that, these would be multiplied together, so that would be product rule. But because there's no x, that x is not there, that means that it has to be a chain rule. 2x is plugged into it. So what I'll do from here is my outside is sine x, and my inside let me make this a little smaller here. My inside is 2x. So the chain rule says take the derivative of the outside. So the derivative of sine is cosine. Keep the inside. So I'm going to keep 2x plugged in times the derivative of the inside. So my inside was 2x, so I'm going to multiply this by 2. And I can just put it right out in front. So just keep telling yourself that. The chain rule says you want to take the derivative of the outside, keep the inside, times the derivative of the inside. The more you say it, the easier it gets. The easier it gets to for you to use it. So let's label our functions here, so that way we don't get all confused here. This is equal to f prime of x. So that's our derivative right there. F prime of pi over 2 means we're going to plug in pi over 2. So we have 2 times pi over 2 plugged in here. And so these 2's will cancel out. We get 2 times cosine pi. And cosine of pi is equal to -1. So -1 times 2 is -2. Okay, and that's going to be our derivative. Hello to some of you I see have logged on now. We are going over the practice test that we started in class yesterday that hopefully most of you have already gone through, but I'm just going to go through and explain some of these. Make sure if you have any questions along the way, if you need me to slow down or repeat something, make sure you leave a comment there and I can check that out and see. So we've done numbers 1 and 2. Number 3, f of x is equal to x minus 2 squared times cosine 2x. So we want to find f prime of 0. What we need to make sure and do is pick the derivative rule that's going to use the whole entire function. Because I know some of you are going to look at this and you're going to say chain rule, because we have x minus 2 plugged into x squared. Or you're going to say chain rule because you have 2x plugged into cosine, kind of just like the one that we did here. That was a chain rule. But what you have to do is pay attention to the fact that these are being multiplied first. So x minus 2 squared times cosine 2x, I'm going to scroll up over here so Riley can see number 1, are being multiplied, so we're going to use the product rule. The product rule is going to take care of the whole entire function, which is what we want to start out with. So f prime of x is going to equal, and we're going to do our product rule. So the product rule says we're going to take the derivative of the first. So when I look at this, x minus 2 squared, that's my first function. Cosine 2x, that's my second function. So I'm going to start by taking the derivative of the first function. And you know what I'm going to do? I'm not even going to take that derivative yet. I'm just going to write x minus 2 squared. Put that in a bracket with a little prime. So that's a little reminder to me that I'm going to go and take the derivative of that piece there. So we have the derivative of the first, or we will at least, times the second function. So I just wrote that second function just the way it's written, plus the derivative of the second function. So that second function I'm going to have to take the derivative of. So I'm going to do the same thing just so I can at least get through the whole product rule, and then I'll go back and find those separate derivatives. So we have the derivative of the second times the first. Okay, So that's our entire product rule. You want to make sure that you take all of the sections into account. So now what I'm going to do is I'm going to go back in and actually find these derivatives. So x minus 2 all squared. I need to take this. X minus 2 is my inside, and x squared is my outside. It's a chain rule. So the derivative of the outside is going to be 2x. Keep the inside times derivative of the inside. Well, the derivative of x minus 2 is just 1. So I could technically write times 1, but I'm just going to save the space there and just write 2 times x minus 2. So that's my derivative of the outside. That derivative is 2x, but I plug the inside in there. So that's how it becomes 2 times x minus 2. And then we have that cosine 2x. Now here, I need to take the derivative of cosine 2x. So this is another chain rule, kind of like the one that we did here. My outside function is cosine x, and my inside function is 2x. So I'm going to take the derivative of the outside. Derivative of cosine is negative sine, but I'm going to keep the inside plugged in. Whoops, keep that in there. Times derivative of the inside, which is 2. We still have that x minus 2 all squared there. Okay, so the more you practice, the easier it gets to kind of do this combination where you have the product rule and the chain rule within the product rule. So that's why when I start out, I like to go through and do the entire first rule. So like we did here, we did the entire product rule, and then we just wrote these little primes to let us know that we need to go back and take those derivatives. And from here, we're just going to simplify. So let's see. Can't really do much to simplify, actually. We have 2 times x minus 2 times cosine 2x minus 2 sine 2x times x minus 2 squared. And that's about all we can do. Oh, and we need to plug in 0, actually, so let's go ahead and do that. We need to find f prime of 0. So take 2, plug in 0, cosine of 2 times 0, minus 2 times sine 2 times 0, times 0 minus 2 squared. And this should all simplify to negative 4. Okay, I'll scroll up there so you can all take a look at what we've done so far. Remember to let me know if you have any questions or if you need me to go back and go over something that I've already mentioned before. Okay, so we are going to take a look at number 4 now. So number 4, f of x is equal to cosine of e to the negative x. So again, when we look here, there's no x right there next to the cosine. So that tells me e to the negative x is plugged inside of the cosine function. So then I know that this has to be a chain rule. We have an outside function, which is cosine, and our inside function is e to the negative x. So to take this derivative, I'm going to take the derivative of the outside. So my outside is cosine x. Derivative of that is negative sine. Keep the inside, So we have negative sine e to the negative x times the derivative of the inside. So my inside is e to the negative x. Well, now in order for us to take this derivative, we have to go ahead and do another chain rule because we have this negative x plugged inside to the function e to the x. So e to the x is the outside function. Negative x is the inside function. So we take the derivative of the outside. Derivative of the outside is going to be just e to the x. Keep the inside, so that's going to become e to the negative x. And we're going to multiply by the derivative of the inside. So the derivative of negative x is going to be negative 1. Okay, so that's our chain rule. We took the derivative of the outside, keeping the inside, times the derivative of the inside. So this whole thing was the derivative of e to the negative x. From here we simplify. Negative times negative gives us a positive. Sine e to the negative x. And what I'm going to do actually, because this e to the negative x is plugged into sine, but this one is just being multiplied. So what I'll do is I'll put that e to the negative x in front there, so it doesn't get confusing, and that way I can avoid having to write parentheses at the end there. And that's our derivative there. So this one was actually a double chain rule because we had outside function cosine, this was our inside function, and then negative x was plugged into that. Alright, so that is number 4. Make sure and type in any questions that you may have as we're going through these. Number 5, we have f of x is equal to e to the 1 over x. So this is also a chain rule. It's kind of like the way we just did the derivative of e to the negative x. So e to the x is our outside function. Our inside function is 1 over x. So we're going to take the derivative of the outside. Derivative of the outside of e to the x is just e to the x. So we have f prime of x is equal to e to the x, but we need to keep the inside, so it's going to stay e to the 1 over x times the derivative of the inside. So 1 over x, always remember, we can change this to a power. So this x really has a power of 1, and when you flip your fractions, you can change the sign from positive to negative or negative to positive. In this case, it'll be positive to negative. So we have x to the negative 1, which is good because now all we have to do is use the power rule. And the power rule says we're going to multiply that negative 1 to the front. So we'll have negative x and subtract 1 from the power. So negative 1 minus 1 is negative 2. So we have e to the 1 over x times negative x to the negative 2, and that's our derivative. It was just a chain rule. This is our derivative of the outside, but keeping the inside plugged in. This here is the derivative of the inside. You can always do this, so if you had something like 1 over x to the 4th, that would be the same thing as x to the negative 4. If you had something like 3 over x to the 5th, this would be the same thing as 3x to the negative 5th. So you can always take those, turn them into powers, and then you can take the derivative of these pretty simply. For example, here, if I wanted to take this derivative of this function here, well, that would just be negative 4x to the negative 5. Multiply the power to the coefficient and then subtract 1 from the power. Same thing here. You would get negative 15x to the negative 6. So just our power rule. And this was our derivative. Actually, we should rewrite it. Let's go ahead and rewrite this, because we don't want to have this negative power here. So e to the 1 over x is going to stay like that. Actually, we could put the negative right in front there, the negative that comes from this right here. And x to the negative 2, that's going to become 1 over x squared. So when you put this all together, it's going to be negative e to the 1 over x, all divided by x squared. And that simplifies it. So we no longer have any negative exponents because we flipped that exponent there, made it positive, and put it all together. Okay, I'll just scroll up again. For those of you who are just tuning in, you can take a look at what we've done here. We started with the absolute value function here, and we determined that finding the derivative at a corner does not exist. So that was our solution here. Number 2, we had to use a chain rule. Number 3, we had to use a product and a chain rule. Twice, actually. So this was 2 different rules there. Number 4 was a chain rule. Actually, it was a double chain rule. And number 5 has been a chain rule. Let's take a look at number 6. So arctan is the same thing as inverse tan. We just got to memorize these people. Gotta memorize them, gotta memorize them, gotta memorize them. If you need to make flashcards, do that. You just need to remember what these derivatives are. So, as long as you remember your derivatives, you just have to pay attention to what is being plugged into it. So if this was just arctan x, then your derivative is just the regular derivative rule, which would be 1 over 1 plus x squared. So you should see that if you look at your list of inverse trig derivatives. You would see that there. But take a look here, we have 2x that's being plugged into that x. So that means we have to use a chain rule. So the chain rule says we take the derivative of the outside. So our outside function is this arctan of x, what we have here. So this is the derivative we're going to use, and we're going to plug in our inside to that x there. So it's going to look something like this. We have 1 over 1 plus 2x squared. So that's our derivative of the outside, keeping the inside plugged in. And now we just have to multiply by the derivative of the inside. So the derivative of 2x is just going to be 2. And you can go ahead and take that 2, put it in the numerator. 1 plus 2 squared is 4, x squared. So that would be your derivative here. And this was a chain rule. So hopefully the more we see these kinds of problems, the easier it's getting for you to determine what your inside is. just like for that one. Okay. Remember, type in any questions that may come up as we're going through these. If you have any other problems that you want me to go over aside from these. So, number 7, we need to take the derivative of x times root 3x minus 1. So, first of all, we have two functions here, x and root 3x minus 1. These are being multiplied, so that means I'm going to be doing a product rule. So I'm going to start out with that product rule that says take the derivative of the first function, but I'm just going to do the same thing like I did last time and just put a little reminder that I'm going to take that derivative times the second function. So my second function is root 3x minus 1 plus derivative of the second function. So I'm going to take the derivative of 3x squared to 3x minus 1 times the first function, which is just x. Okay, so that is my whole product rule. You want to start out with that rule, and then you see we're going to come back here, and I'm going to come back here and take these derivatives. So, derivative of x is just 1, so that leaves me with root 3x minus 1 in this section here, because this just becomes 1 times that there. Here, I need to take the derivative of root 3x minus 1. Well, if you look at that, this in itself is a chain rule. We have 3x minus 1 all to the 1/2 power. So my inside function is 3x minus 1, and my outside function is x to the 1/2. So I'm going to take the derivative of the outside. Derivative of x to the 1/2 will have to be 1/2 x to the negative 1/2. I didn't write the x because I'm going to keep the inside plugged in. Remember, it's a chain rule. Times the derivative of the inside. So derivative of 3x minus 1 is 3. This all in brackets here is the derivative of this part right here. And then we still have the x right at the end there, so I'll multiply that. From here, we're just going to simplify a little bit. This root 3x minus 1 has to stay in the front there. 3 times 1/2 is 3/2, times that x is going to be 3x over 2 times 3x minus 1 to the negative 1/2. Again, we have a negative exponent, so I can flip that. And it's going to become 3x over 2 times 1 over 3x minus 1 to the positive 1/2. So we had a negative 1/2. We can flip it, find the reciprocal of this function, and change that sign to positive. And remember that 1/2, power of 1/2 is just a square root. So let's see if we can simplify this all together. These two fractions are being multiplied, so my numerator is going to be 3x, and my denominator is going to be 2 root 3x minus 1. Remember that exponent turned to a root. So that should be our answer here. Just checking my solutions to make sure I did this all correctly. Yes, okay. we go. All right. Number 8, I see an natural log in this function here. Y is equal to the natural log of t divided by t. So what is the rule that is going to take care of the whole entire function? Well, ln t is divided by t tells me this is going to be a quotient rule. So quotient rule says we're going to take low d high. So again, I am using this technique here where I'm just going to remind myself that I'm going to take the derivative and then go back and find the derivative later. So we have low d high minus high d low, square the bottom, and away we go. So now that I've done that whole quotient rule, I can go in and take those little derivatives. So the derivative of ln t, well, I know the derivative of ln x is equal to 1 over x. So it's going to be the same thing for t. We're just going to have the variable t. So it becomes 1 over t minus ln t times the derivative of t. Well, the derivative of t is just going to be 1. So I don't really need to write anything there. And that's divided by t squared. T times 1 over t, that is going to cancel out and give me 1 minus ln t all over t squared. And that is as simplified as that's going to get. So we're almost through. We've gotten through a lot of these. We just finished number 8. What rule did we use here? We had to use the product, and we used the chain rule. So we used 2 rules in this case. We used chain here, chain, chain, product and chain. You see that chain is a pretty popular rule that we have to use often. So you really want to make sure you feel comfortable with that rule. Now number 9 says let f be a differentiable function such that f of 1 is equal to 5, f of 2 is equal to negative 3, f prime of 1 equals 4, and f prime of 2 equals 2. We're going to let the function g be differentiable, and g of x is equal to f inverse of x for all x. What is the value of g prime of 5? Okay, so there's a lot of information. We should try and figure out some way to organize this. So the first thing that I know is g of x is equal to the inverse function. So anytime we see g of x, for example here, this is really asking us to find the derivative of the inverse of f. So keeping that in mind, we're going to go ahead and take a look at some of the points that we have. So on the function f, we have the point, and you can actually create a table, you can list your points, whatever you want to do. I'm going to make a table here. So this is for our f of x. When x is equal to 1, f of x is going to equal 5. So that's just based on what they told us right there. They also told us that when x is 2, f of x is equal to negative 3. So I'm going to plug that right there. And then they told us f prime of 1 is equal to 4. So I'm going to do f prime column. F prime of 1 is equal to 4, and f prime of 2 is 2. So I've created this little chart here. But what we really want to think about is the relationship between f of x and f inverse of x. Because remember, we're trying to find the derivative of the inverse when x is equal to 5. Well, this x equal to 5 is really the x of our inverse function, which is really the y value in f of x, because they're inverses of each other. So if we have the point f of 1 equal to 5, we also have the point f inverse of 5 is equal to 1. So what we do here, since we're taking the derivative of any inverse function is always equal to the reciprocal of the derivative of its original function. So this is a rule that you want to make sure you remember, you keep in mind always. The reciprocal of this reciprocal of the derivative of f is equal to the derivative of the inverse function. So if we're trying to find this value to be 5, it turns out that this is actually 1 on f. So a little tricky, a little hard to wrap your mind around sometimes, but this x value is the x value of the inverse function, but it's really f of x. And that transforms into this x value here. So now all we need to know is, what is f prime of 1? Well, f prime of 1 is 4. So our derivative of the inverse at 5 is equal to 1 over 4. It's as simple as that. You just have to make sure you can understand that relationship, that these are essentially switched when it comes to inverses, and this is how you find the derivative. I can take that back here, just like that. Okay. I'm going to check here, make sure we don't have any questions. Okay. So we're coming close to the end here. I don't want to go too long on this. So we're going to do some implicit differentiation here. So how do we know we're using implicit differentiation? Well, we see a y in there with an x. So we're going to be taking the derivative of this whole function all at once. So I'm going to start out here taking the derivative of y squared, but we're taking this derivative with respect to x, or here that says in terms of x. So that means anytime we take the derivative of y, we have to multiply it by dy over dx or y prime. So I like to use dy over dx. So what I'm going to do is take the derivative of y squared, which is 2y, and multiply that by dy over dx. Next, I'm going to take the derivative of x times y. So these two are being multiplied, which means I'm going to take x times the derivative of y. So the derivative of y will be dy over dx plus our second function times the derivative of our first function. So this is our product rule. Actually, I think I did it backwards as from the way that I've taught you guys. Derivative of the first function, let me go back here. derivative of x would be 1 times the second function plus the derivative of the second function. So the derivative of y is 1, but we have to multiply by dy dx times x. So that's our product rule here for x times y. This minus is going to have to distribute, so I put brackets around here to remind me that I'm going to distribute that. Plus x squared, so the derivative of x squared would be 2x. And we still have to continue past the equal sign. So we have to take the derivative of 1, which is 0 here. And that is our whole derivative all done for each of these terms. And what I'll do now is simplify and isolate that dy dx. So that minus y minus x dy over dx plus 2x is equal to 0. Every term that doesn't have a dy over dx in it is going to get moved over to the other side. So this minus y and this plus 2x, I'm going to move them over. So I have 2y times dy dx minus x dy dx still on this side. I'm going to add the y over, so y minus 2x is going to be on this side. Now what I can do is factor out dy over dx. That leaves me with 2y minus x equal to y minus 2x. I will divide to get that dy over dx by itself, and that solves for our derivative. So with implicit, you want to go term by term, and our terms are whenever we have these plus or minuses, they're breaking down our terms. So this is one term, this is another term, that's another term, and that's its own term. So you want to take each of those derivatives separately. This right here had to be a product rule. The rest of them, y squared, x squared, those were power rules, and then derivative of a number is just 0. Okay. Remember, your test is going to be on Friday, so we'll take some time tomorrow if you want to go over some more of the inverse. I see some of you still want to practice a little bit more of the inverses. Remember that there's IXL section on this, and we can go over some of that tomorrow. Implicit differentiation, you definitely want to make sure that you can do this. There's a section on IXL for that as well. I see a question here. Do you think you could post this entire video after you are done with live? So I believe this video is going to just stay on this channel. I'll double check that or make sure that it gets on the channel. So it should be there. Don't worry. In case you missed some parts, you can always go back and take a look at how to do some of the other problems. So I'm going to do just one more here so we can take a look at some more implicit differentiation and then see how to plug into this. So x times y squared minus 2x equals y to the 4th minus 1. So remember, we're going to take derivatives of each of these terms here. My first term, x times y squared, is two functions that are being multiplied. So I have to use the product rule to take this derivative. So my first function is x, and then my second one is y squared. So I'm going to take the derivative of the first. Derivative of x is going to be 1, times my second function, so y squared, plus derivative of my second function. So derivative of y squared is 2y, but remember you have to multiply by dy dx times derivative, or sorry, not derivative, times the first function, times that x. So this part right here, this is our product rule to find the derivative of this part right there. And then we're going to keep going. So we have that minus 2x. Derivative of 2x will be 2. And that's going to equal derivative of y to the fourth. So 4y cubed, but since we're taking the derivative of y, you have to multiply by dy over dx, minus the derivative of 1, which is just 0, so I'm not going to write that down there. And this is that first step. We go through the whole function and find the derivative of each of these terms here. Sometimes you'll have to use the product rule, maybe a quotient rule will pop up, chain rule. You just, doesn't matter what it is, you go through term by term and do whatever rule you see is necessary. From here, we're going to simplify. So that's going to become just y squared plus 2xy dy over dx minus 2 equal to 4y cubed dy over dx. Now at this point, since we want to find the derivative at the point 0, -1, we could just plug in these values here. So 0 is the x value, -1 is the y value, and then solve for dy over dx. But I actually want to just practice solving for dy over dx, since it is something that you have to do, like in the last problem that we did. So what we'll do first is make sure that any terms that don't have dy over dx in it are going to get moved over to the other side. And if we have a term like this one that has dy over dx in it, I'm going to move it over to the left side. So that way we have all of our dy dx's together on one side. And it's going to look like that. And then I'm going to subtract that y squared plus 2. These guys are getting moved over to the other side. Dy over dx is what we have in common here. So that leaves me with 2xy minus 4y cubed equal to -y squared plus 2. And then I will divide by all of this. So I get -y squared plus 2 divided by 2xy minus 4y cubed. That's our derivative. If it was asking you just for the derivative, that would be your answer, but we want the derivative at this specific point. So what I'm going to do is plug in those values. We have -1 squared, since our y value is -1, plus 2 over 2 times 0 times -1, well, that's going to go to 0, minus 4 times -1 cubed. So I have that -1 being squared is going to become a +1, but there's this minus here, so that's going to be -1 plus 2 all over, well, that's going to become 0, and this is going to become a +4. So -1 plus 2 is going to be a 1/4. And that should be our solution there. Alright, so this has been about almost an hour long. We got through a good amount here. Remember, we're going to go over some more things tomorrow and just do a lot of practice. Make sure you go on iExcel, do a little bit today, maybe a couple problems, and then tomorrow, that's all we're going to be doing in class is iExcel. So I'm just kind of scrolling through here so you can take a look at these problems. I'll have a practice test for you tomorrow, which will be similar problems to this one, so that way you can kind of test your knowledge and see if you can do it on your own. And this is going to conclude our live stream. So I'm going to take a look here, see if you have any other questions. I don't seem to see any on here. So make sure if you do any other questions come up while you're studying, let me know tomorrow and we'll go over them. And I'll also be available after school tomorrow. All right, you guys have a good night and I'll see you tomorrow.